Okay. Nice easy lesson today looking at linear functions. So we got some notes here, so if you have the paper that you printed out, you can just write on here. Otherwise, you might just want to put this down into your notebook. So linear function, so first part, we're just differentiating what is linear, what is not. So it says it can only include the operations of addition. Should have made this bigger, because I can't write this. Subtraction, can't spell right either. And multiplication. That's an I. Multiplication. Yeah, that sounds right. Of a variable by a constant. Notice how we don't include division. You say, well, Ellis, I've seen y equals x over 2, I don't know, plus 4. And that includes division. And we'll say, well, not quite, because you can rewrite that as y equals 1/2 times x plus 4. So really, we're still just doing multiplication. So when we say we can include division, it's talking about like this one here where x is in the denominator. Because if you graph that, you will not get a straight line. And probably take a look at these. If you remember from last year, you might recognize what some of these graphs will look like. If not, you could go to your favorite graphing website. You can type in these equations and see what they look like. Get some interesting graphs. Let's see, nonlinear function has other operations. There should be an S there. Other operations that when graphed will not create a line graph. Won't make anything other than a line. Okay. But really our focus is, what is slope-intercept form? And that you should be very familiar with. Y equals mx plus b, where m is the slope and b is the y-intercept. Okay. So if they were to give you an equation y equals 3/4 x plus 8, we would say m is the number being multiplied by x, which is 3/4. B is the y-intercept, which would be positive 8. Okay? And what you're going to have to do on the practice today is it's going to give you an equation in slope-intercept form, and you need to identify the x and y-intercept. So the y-intercept is nice and easy. It's just what comes at the end. What is this constant at the end of our equation? So our y-intercept here would just be -4. Okay? Our x-intercept is a little bit more work. We want to know what is the x value when y equals 0. So we're going to rewrite our equation, only we're going to substitute y with 0. So 0 equals 4/3 x minus 4, and then we just solve for x. So we'd want to get rid of this -4 first. So we do +4 to both sides. So that gives us 4 equals 4/3 x, and then this cancels out. If we need to get rid of multiplying by a fraction, remember the simplest way would just be to multiply it by its own reciprocal, which is just the fraction but flipped upside down. So to get rid of times 4/3, we would just multiply both sides by 3/4. And then if we are multiplying a whole number by a fraction, remember we can rewrite that as the fraction over 1. So all of this will cancel out. We could either multiply straight across or we could simplify first. So if we have a 4 on the top and bottom, those would both cancel out. And you'd be left with 3/1. If you're not into the whole canceling thing, because that seems like too much work for you, we'd say 3 times 4 is 12, and 4 times 1 is 4. So we'd have 12/4 equals x, and then 12 divided by 4 is 3. So our y-intercept would be -4, and our x-intercept would be +3. And there are answers. So for each of our problems, they all look pretty similar. So the y-intercept is always just going to be this number all by itself. And then for the x-intercept, we would simply rewrite our equation using 0 for 1. So 0 equals 1/2 x plus 4. And then you go through, you solve for x. Okay, you do that, was it 12 times? There you go. Do that 12 times, solve multiple choice. So you can narrow down your answers pretty easily. Let me know if you have questions. All right.